In this video, we're going to be looking at constant velocity that's being plotted on a velocity versus time graph, and then using that information to sketch a position versus time graph. So there are several different constant velocities as seen in each of these segments. So there's a constant velocity with this one, this one, this one. Every flat line is a different constant velocity. The velocity is going to be on the y-axis here in a velocity time graph. So for this, it's pretty easy to get the velocity. I'm just looking at what is the y-axis value. In this case, it's v equals 3. In this case, it's v equals 2. Then it drops to a speed of -1. And then it stopped for a second. And then it's going to be at v equals +1. One of the trickiest parts with going backwards to the position time graph here is that where do we start? You can think of this position axis as being a tape measure, and so a common place to start would be 0, but really it doesn't matter where you start. Sometimes I like to see what the velocities are doing. If they're moving positive, then maybe I start down here to give it some room to move up the tape measure. If the velocities are for some reason starting with negative values, I may want to start away from 0 to give it a chance to move backwards. In this case, since the velocities are +3 and +2, meaning there's positives, I can start at 0. It really doesn't matter where we start. What does matter though is the velocities telling us the slope of this graph. So for the first 2 seconds, the speed is 3, which means that this is going to be going up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1 for the first 2 seconds. Then it's going to, from time 2 to 5 seconds, it's going to be going up 2 and over 1, right? This is telling us how many meters it's traveling each second. So I would be going up 2, 1, 2, over 1, up 2, 1, 2, over 1. And I'm going to do that all the way to 5 seconds. Up 2, over 1. So it's just a little bit less steep than it was during the first 2 seconds. Now we're going to be going -1 for 2 seconds. So it's going to be going down 1 over 1, down 1 over 1. At this point, it's stopped. So whatever position it has, in this case, 10 meters is where it's standing on a tape measure, it's just going to hold that flat. And then it's going to be moving up 1 over 1, up 1 over 1 for the last 2 seconds. We'll try one more. Again, it doesn't matter where I start, I'll just start at 0. But the steepness is going to be 0, right? So that means that this is going to be holding whatever position we start with. Then it's going to be going 1 meter per second, right? So that means it's going to go up 1 over 1. Then it's going 2 meters per second for the next second. So it's going to go 1, 2 for every 1 second. Then 3. 1, 2, 3 over 1. So it seems to be just getting, the segments keep getting steeper, which makes sense because the segments keep getting a faster velocity value. Now it's going to jump to v equals -2 meters per second. So I'm going to go down 1, 2 over 1. We're going to do that for another second, down 1, 2 over 1, because from time equals 2 to 6, we're subtracting 2 meters each second. We're then going to be stopped, which means we're going to hold the position we're currently at for 2 seconds. And then here it will be 1 meter for every second. And there's our position time graph. These are both going to describe or depict the same constant velocity motions, just in different ways because they are plotting different values on the y-axis.